Well, last time, this is where we ended off, right? We did Hello World. That's all it was. It was a program. And fortunately, I don't know about you, but I find that program somewhat intuitive in what it does. Well, let's see if I can get this. Is that better or worse? Is that better or worse? Yeah? But do you like the light? No? All right, we'll go with this. I find it kind of intuitive. What does it do? Well, it prints the phrase, hello world. And fortunately, the function, that's what we call print there, it's a function called print, prints things to the screen, which is great. So we're printing the phrase hello world. In fact, those letters that we call there that make a sentence, I don't know if you call it a sentence, that statement, whatever, it's in quotes, and that's important. That means we call it a string, which is a type that we're going to talk about very shortly. But all this program does is prints the phrase, hello world. That's it. Raise your hand if you did this yet. Great, you wrote a program. It's a simple one. It's a small one. But it's a program. There's no ifs, ands, or buts about it. So if you did that, you're officially a programmer. Now, one thing I'd like to emphasize here is, the function print actually take a moment and gain an appreciation for what that print function actually does. Consider that it needed to know how to actually display it to the screen, like what pixels to turn on and what not, and where on the screen. So there's a lot under the hood, under that print function, right? But fortunately, we didn't need to know. We didn't need to know. Who here drove to the university today? Now, for those of you that drove, could you build an internal combustion engine from scratch? No, I don't think so. Do you need to in order to drive to the school? No. No, because we interface with our cars, our vehicles, at a much higher level of abstraction. How do I get to school? I sit down, I turn the key, or maybe fancy hit a button. Reverse, gas, brake, steer. That's how you interface with your car. But if you really think about it, well, there's a heck of a lot more actually going on under the hood. A lot more complex stuff. But it doesn't really matter. Some of that complexity is hidden from you. So there are different layers of abstraction involved in programming, and we'll get a sense of that as we go. Any questions about Hello World? Did anyone try to get it going, but it didn't work? One thing, if you go to settings, editor, there's a lot of options for you, but one of them, show line numbers, I recommend that you turn on. It makes it easier to refer to specific lines of code. If there's an issue, you'd be like, on line 17, blah, 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 blah. And it'll eliminate any confusion of someone, because every year someone will try to do one space print, and it won't work. It'll be like, Python will say, what the hell is that? It's because that one's not really there. It's just the line number. Cool. So yeah, any questions before we move on? Who here got it working their first try? That might be the last time that ever happens to you. All right. So there we go. You're officially a programmer. So the next topic, print, values, variables, and types. Print, we've already seen. Print is a great way to output information. The way it was being output was to a screen so a human could read it. But then we have values. Values are going to be things like 7. Right? Or the phrase, hello world, is a value. Variables, those are like boxes that we can store information in for later. It could be a stand-in for a lot of things, kind of like in math, variables in math. And types. Well, the values in the computer have different types associated with them. Like a number is different than the string hello world, right? They're different. So, first of all, let's take a moment. Raise your hand if you've used the word computer before. Of course. Raise your hand if you used the word computation, or at least know, you've heard the word computation, right? Programming, you've heard the word programming. But let me ask you, who can tell me what computation actually means? What does that mean? I'm not being tricky. You've all used the word, or maybe you haven't used it, but you've heard it, you're familiar with it. And then I'm going to ask you, well, what is computation? What does that actually mean? And you're kind of left going like, well, it's that what were you going to say? Input, outputs? It could be part of it, yeah. Yeah, doing some sort of like operations, steps of stuff, yeah. It's kind of a funny word that we're all used to, but how many times have you thought, like, what does that actually mean? Can someone point to a computer? You're pointing at your laptops. Great, cool. Can you point to another computer? People grab their phone. Fantastic, great. But what you're pointing to, so you have to understand, the word computer doesn't necessarily mean these boxes. Computation, or a computer, is something that can do computation. Computation is, something could have input, output, different states, do different actions depending on the states and whatnot. The word computer is far more general than those boxes that you're sitting in front of or your phone. The type of computer that those boxes are in your phones, they're the same. But something as simple as a lock is a computer. It is. It's got a state. You can apply a key to it. It changes its state. Depending on if the state's correct, it might actually have some output, unlocking the door. It's a very simple computer, but it is no ifs, ands, or buts about it. It's a computer. People will sometimes argue, especially in neuroscientists, some of them will start arguing, the brain's not really a computer. No, it absolutely is. There's no ifs, ands, or buts about it. Your brains are computers. They are. They're very different than those boxes in front of you. They work differently, but they are doing computation. They are computers. There's nothing to argue about. It is by definition, and if you want to argue with it, we're in the realm of semantics, and you're also wrong. You are computers. Your brains are, by the definition of what a computer is. Obviously, today, when you hear the word computer, you're thinking of those boxes in front of you, right? Because that's what we call them. But don't forget that computation is far more general. It happens in nature all the time. There are how many, think of the cells in your body. They're doing their thing. They're just following some instructions based on some chemical configurations on how they interact with other chemicals to produce other chemicals that will then interact with other, and so on and so on and so on. There's a hell of a lot of computation taking place there. Who here has ever sorted something before? Have you ever sorted something? Yeah, you just computed something. You didn't need a computer to do it, but you sorted something. Have you ever searched a pile of things for something? Yeah, that's computation. You're searching for something. You're performing some form of algorithm, which is just a fancy way to say set of instructions. Like literally, who here's baked a cake before? Or cookies or something similar? No, never? You've done? Oh yeah, you have, all right. That's an algorithm. It's a more formal mathematical word for it, but it is. When you got in your car and drove to the university today, you followed a set of directions and whatnot that got you from point A to point B. If you made it, your algorithm was correct. If you didn't, well, I don't know where you're not here, you're lost. It wasn't correct. Point is, these terms are far more general than we might be used to. And I'm not playing this gotcha with definitions. I'm not being like, oh, technically it really is the same. No, it is, and it's important to realize this. So what is a program? Who here ate breakfast today? Raise your hand. Who here at the least would know how to make breakfast if they wanted to make breakfast? Okay, here's what I want you to do. I'm going to give you like 4 minutes to talk to a partner or something to explain how you did make breakfast this morning in as much detail as you can, such that someone could redo it. And if you didn't make breakfast, well, pretend you did. And do that. Take a moment and explain the steps, step by step, how you made breakfast this morning. Go ahead and do it. All right, it's getting quieter, so I'm guessing you're done. There, if you just did it there, you explained an algorithm. Again, I'm not being silly with definitions. That's what an algorithm is. So who had eggs for breakfast? All right, you're going to tell me what you explained to him for the program. I'm you. I'm in your kitchen. So tell me what to do.
Okay, first go to the fridge.
Where's the fridge?
The fridge is on your right.
Like this far or over here? Like, I'm still going right. Tell me when.
Now.
Okay, it's over here.
Then you go about 3 steps forward.
3 steps. What's a step? Oh, you mean these things. Okay, right. 1, 2, 3. Is that too far?
That's perfect.
Perfect, all right.
Absolutely perfect. And you're going to reach out with your right arm and have your hand open on about a 90-degree angle from your body. There it goes.
Like this?
You're going to grasp and pull that arm back towards you.
To be clear, the fridge is right here? Or was I supposed to be like this? Ah, okay. See, we would have had a bit of an issue, I think. Good thing I checked. Okay, grab, okay, my hand, and grab.
Yeah. Okay. Pull your arm back towards your body so your elbows touch your body.
Okay, probably going to swing like this, but yeah, okay.
And then I guess take one more step forward to get closer to the fridge. Look on the second to the top shelf.
All right.
Do your best attempt to grab the eggs.
I mean, I could use this hand, I guess.
With the left hand, reach out and grab the eggs.
You got them. How many do I have in my hand? Okay, of course, I'm being a little mean right now. I'm being very mean. Because I could play this game until we get down to subatomic particles. Right? I could play this game of oh, what's a step? Oh, lift your leg. How do I lift my leg? Oh, you just, you contract your muscles. What's contracting your muscles? Oh, okay. Well, really, now we're going to... I could play this game forever, right? Realistically, if you're talking to a human, you'd say, okay, go grab some eggs from the fridge, grab a frying pan, crack them, wait a couple minutes, you've got eggs, right? A human would understand that level of description. I was being kind of nasty, because what I was doing is I was trying to get you to be less abstract, more specific. But we operate at a certain level of abstraction. And that's normal. But I was trying to push it to see how low I could go, right? And I was being kind of nasty, kind of mean. Computers often operate at a pretty stupid low level of abstraction. Sometimes we're lucky and we've got things like a print function that actually does a lot for us. Sometimes we're not, and we got to build things from the ground up. But there we go. That was an algorithm. Beautiful. Everyone give him a hand for that. I put him through it, that's for sure. What kind of computer was executing that algorithm? A human, right? I was doing it. I started, I grabbed things, I changed states, and at the end of the day, when I was done, I ended up with cooked eggs for breakfast. Great. It wasn't a box on my desk, it was me. Or you, if you ate your breakfast. So, what is debugging? You're supposed to be, you can sit down if you need to, or are you in the wrong place? 161? All right. Debugging. There's programming. Someone was just coming in, they looked lost. There's programming and then there's debugging. What's debugging? Well, honestly, it's really what programming is, like I was saying yesterday. Most of the time, your code's going to be wrong. It doesn't matter if you're new or have been doing it for decades. That's the case. Debugging is the process of addressing the bugs in your code, the bugs being mistakes, errors. And there's different types of bugs. They're all over the place. Realistically, expect to be debugging a lot. Realistically, expect that to be what you're doing most of the time. That is what programming is. Don't get it in your head that you should be good at it and sit down, whiz, and get it done the first time. That ain't going to happen. You're going to be wrong every time you hit run on your program until you're right. Sometimes you got to hit run 7 times. Sometimes you got to hit run 107 times before it gets working. Presumably you've changed it in the meantime. It doesn't just start working. But you're going to be wrong a lot. You're going to be wrong a lot more than you're right. Get used to it. But that's the process. That's what you need to be expecting. If that's happening to you, you're doing it right. If you're somehow getting it right every time, I'm suspicious that you are. Something else might be wrong. Your computer's probably broken because it's tricking you into thinking it's working. Who here's seen a Python error yet? Was anyone dicking around in Python and a bug, like something yelled at you? I saw one earlier when I tried it. Yeah. When you saw, for those of you that saw a bug that wasn't the one that I just showed, did you understand what it was trying to tell you? Do you remember what it was trying to tell you? You don't remember the specifics. Yeah, and it'll be like, I don't know what that is. Yeah, like if I did this, one print, right? Syntax error. Well, syntax error, there's a problem with my syntax. All right, that one's pretty straightforward. In fact, it's kind of helpful. It's kind of showing me okay, there's something wrong around here. It's got a little arrow. I mean, really the error isn't with the print, it's with the 1. But it's also kind of with the P in the print because it's followed by this, it's the whole thing. There's that. I could say like 1 plus hello. This is what you mean, right? It's going to be like, I don't know, what? What does that mean? This error message, well, what does it say? Unsupported operand types for plus, int and str. Int, who wants to take a wild guess what int means? Integer, yeah, good one. What do you think str is? String. That was the word I used to mean like words. And what that means is, well, operand, who remembers their grade 5 math? What does operand mean? Well, hold on. You might be thinking operator. To be fair, you probably learned this when you were this big and never used the words again, so we can refresh your memory. An operator is something like plus, right? That's an operation you're performing on something. An operand is what you apply it to. So 1 plus 1, the operands are 1, and the operator is 1, or is the plus. So here it's saying, well, okay, you're using plus. And there's something wrong with the operands you're using. It's saying, what the hell am I supposed to do with an integer and a string being added together. The computer can't do it. And if you're wondering why can't the computer do it, well, let me ask you something. I need a volunteer. You. What's 1 plus hello? Come on, what is it? That's a, yeah, see, that's what Python thought too. What the hell is this? That's a stupid question. That's not a thing. That's not an admissible statement. There's no such thing as 1 plus hello. I mean, maybe if we defined, well, if you add an integer and a string, this is how I want you to operate. Okay, fine. But as of now, that doesn't look particularly, 1 plus hello doesn't really make a lot of sense, does it? So of course Python can't do anything with that. It's nonsense. Languages. Raise your hand if you speak English. Well, very good. So, English is a natural language. Programming languages are formal languages. And there is an important difference. Now, we like our formal languages, like our programming languages like Python, to be similar to natural language in a way that we can understand it easily because we're familiar with it. But natural languages have a lot of flexibility that we really aren't allowed to have with computers, or at least with formal languages, I should say, right? You can have ambiguity in natural language. You can do a lot of beautiful things with natural language. You know, we've all read like poems and novels and whatnot, and there's a lot of like interesting things that goes on with just even how someone's communicating, right? You can communicate a lot with very little with natural language sometimes, right? And how the words are said. It's interesting. In formal languages, a lot of that's not very good or helpful, or if not, very detrimental, very problematic. So here's an interesting thing. And this interesting thing is actually very related to one of the most important discoveries of the last century. But there is a question where, like, okay, I have a computer. You guys are computers. Those boxes are in front of you are computers. Your cells are computers. Hell, even a lock is a computer. Given a sufficiently sophisticated computer, can I compute anything or everything? Is it possible that every single thing could be like computed, solved? Seems like an interesting question to ask, right? Does anyone know the answer? Yes. You know the answer? You think the answer is yes? I got bad news for you. One of the most interesting discoveries of the last century is that it turns out there's shit out there we don't necessarily know what we can't compute. And there's a flip side of this with mathematics about like proofs and whatnot too. We know that there's stuff that we can't solve, but we don't know what those things are, which is kind of mind-blowing. But that's well beyond the scope of this course. That's fairly sophisticated stuff. But let me put it like this. This statement is false. What does that mean? Someone tell me what that means. It's not a trick question. I'm just asking you to tell me what it means. I mean, it's kind of a trick question. It's not, but it kind of is. Pardon? Yeah, we kind of got a bit of a conundrum on our hands, don't we? Raise your hand if you 110% absolutely understand the problem. Raise your hand if you're like, where's he going with this? And everyone else who didn't raise your hand, I don't know what's up with you. So here's the issue. Let's read this statement. This statement is false. So what does that mean? How do I interpret that statement? That it's not true. This statement is false. Well, that statement is telling me that basically I shouldn't trust it, right? This statement is false, so I shouldn't trust it. Therefore, if the statement is false, and it's telling me that it's false, that means whatever it's saying, I should disregard. Are we starting to see a bit of the issue? Okay, if this statement is false, okay, then I shouldn't trust it. I should do the opposite of what it's telling me. And it's telling me it's false, which must therefore mean it is true, right? So it's true. So if I'm not to trust it, it must therefore be true. So if it is true, well, what does that mean? That means it's false. Wait a minute. If the statement is false, that means I shouldn't trust it, so it should be the opposite of what it's saying, which is that it's a true statement. And then if it's a true statement, I should listen to what it says, and what it's saying is that it's false. And if it is false, it should therefore not be false, which is true. We're just going to go around in circles forever on this. How about this? I can rephrase this to a slightly similar one. What's going to happen to Pinocchio if he's sitting there? Raise your hand if you don't know who Pinocchio is. Be honest. I can explain. Okay. Pinocchio, a little wooden boy. If he lies, his nose grows, right? It's Pinocchio. So Pinocchio's sitting right here. And Pinocchio says to us, my nose is going to grow right now. What happens to Pinocchio? He turns into a real boy. Nice. What would happen? If Pinocchio is sitting there saying, my nose is going to grow right now, and it does grow, well, hold on. His nose only grows if he's lying. So if he's sitting there saying, my nose is going to grow now, and it grows, he wasn't lying. Therefore, it should never have grown in the first place. I can't tell from the looks on your faces if you're like, yeah, whoa, or if you're like, I have no idea what he's talking about. Look, when Pinocchio lies, his nose grows. So if he says, my nose is going to grow, it's only going to grow if he lies. So if it does in fact grow, he was lying. Because he said it was going to grow, and if it grows, he was telling the truth, which means it should never have grown. If he's sitting there and he says, my nose is going to grow now, and it doesn't grow, that means he was lying, which means it should have grown. Pinocchio should never say that phrase. Because I don't know what's going to happen. Unless it does exactly what you said. Maybe that's what does it. They're paradoxes. They conflict with each other. This statement is true, or this statement is false, means it's true, which means it's false, which means it's true, which means it's false, which means it's true, and so on and so on and so on and so on. Whenever you get self-referential things, that statement is referring to itself. Pinocchio was referring to himself. Whenever you get situations like that, that's where weirdness like that can arise. But it's related to the whole issue of, like, turns out formal languages, we got a problem because paradoxes are a hell of a thing. Any questions about that? Raise your hand if you 100% now understood what I was trying to communicate. Raise your hand now if you're still like, yeah, I don't know. You're a little bit. One person's brave enough to admit it. Half admit it. Yeah. That's not too important that you understood that. So now some terminology. Some of this may be terminology you're familiar with. A lot of this terminology I'm not even going to be using very much in this course because it's not really about like programming or computer science. It's more like hardware types, like your computers type thing. But there's hardware and software. Hardware, that's like your physical computer, your mouse, right? Your monitor, that's hardware. And then there's software, that's like the programs. Like Facebook is software, whatever. Input, output. Input is inputting stuff into a computer, and output is outputting stuff. We saw an example of an output, that print function, that was giving me output. Processors, those are the things in the computers that are actually doing the number crunching. They're the things actually doing all the computing. They're doing all the calculations. Storage, hard disk, solid state. So you've got storage. That's where you store information, like long-term storage. That's where like the code for all your programs is stored. Memory and RAM, random access memory. Memory, that's storage, but it's kind of like my working memory. You can think of like processor, if you're cooking in the kitchen, you're like the processor doing the cooking. Your storage could be like your fridge and cupboards, and the memory would be like your working surface, right? That's where you put all the stuff that you're going to need to do it, and then when you're done, you put it away. Binary, who here's heard that word before? That's like zeros and ones, right? Yeah, binary. Compiling, anyone heard that word before? 1, 2, 3, 4, a couple people. Compiling, that's a fancy way of saying turning the code into something the computer actually cares about and can interpret. Because although I wrote print hello world, the processor goes, I don't know what the hell that is. So there's actually a translation process that converts the code into low voltages and high voltages that actually get run through the processors for the number crunching. So it's like compiling. It's more complex than that, of course, but that's the gist of it. Interpreter, IDE, we won't worry about that. Print. So we've already seen print. And you know what? Let's do another function or activity I've been talking for a while. If you've got your computer and Colab open, write another program, single line program that tells Python to print out some other message. Just do another print, make it say whatever the hell you want. Make it as inappropriate as you want, I don't care. Raise your hand if you're done. Raise your hand if you'll be done in like 10 more seconds. I'll give you 10 seconds. All right, so you use print again. You told the computer in the Python programming language, I want you to print whatever to the screen. And when you hit run, it actually needs to go and get interpreted into something that can actually be like run through your computer and then actually perform what you asked it to do. That's what happened when you hit run. Print is your basic output, right? Print something, okay? There's other forms. You could save things to a file pretty easily. There's a lot you could do. You can play sounds, whatever. But print is very common. You're going to be writing print a lot. In fact, print is very handy for keeping an eye on what's going on in your code step by step. It's kind of like an informal debugging strategy, but we'll get there when we get there. You'll be using print a lot, though. Fortunately, it's easy to remember print. What does it do? It prints stuff. Any questions up until now? I've been talking a lot. I really want questions. This is boring. Yeah.
I mean, it's not necessarily fully relevant to this, but I was just wondering, like, what kind of takes on like AI you might have in this course.
In this, what do you like? How do you mean?
Like, I mean necessarily for like coming up, not necessarily coming up with ideas, but like checking work and looking over, using it as kind of a tool to figure out.
So you mean like, you don't mean like developing AI, you mean using like ChatGPT to help you with something. Yeah. Well, officially my stance is what's in the academic calendar, which is if there's nothing in the course syllabus about it, it means you're not allowed to use it at all. That's the official stance. The reality is, if you are using it as an effective learning tool, I won't know the difference. If you're using it to write your assignments for you, I'll know the difference. I mean, there's a lot of software we can use for detection of that stuff, but you want to know where I'll really know the difference? Is when you get perfect on all your assignments, but you got like 2% on the test. So that ain't going to be, I just get test anxiety. No, you just don't know what you're doing. So if you can use it as an effective tool to help you learn, great. If you use it as a mechanism to cheat, God bless you. Good luck. I didn't really go on my rant this year. One of my favorite things is catching cheaters. I think it's fun. I will take so much time investigating. Because I find it, the joy I get from catching cheaters is immeasurable. It's one of my favorite things to do. So, you want to do me a favor and let me catch you? Oof, you'll make me so happy. And then they always ask the prof, like, well, what do you want as like punishment, right? Because in spite of what people say, oh no, it's not, when you check academic integrity, it's not supposed to be punitive, it's supposed to be educational. What the hell do you not know? Cheating's been wrong since you were this big. What am I teaching you about cheating that you didn't already know? You cheated. It is supposed to be punitive. So they ask, what do you want? And typically the way it goes is if it's your first offense, usually what they'll do, every situation's different, usually what they'll do is they'll give you 0 on that assignment. If it's your second offense, usually what they do, you automatically fail the course. And if it's your third offense, usually what they do is they boot you out of the university. And don't worry, everyone knows. So like if you want to go to another university after, you won't. Now they always ask the prof though, what do you want? And I always advocate for the most harsh punishment imaginable. Because when you cheat, like it doesn't offend me, but I find it, there's a lot of people that have sat in these seats before and are currently sitting in them and will be sitting in them that were here, paid money, they wanted to learn, and they did it, and they learned it. And you're brazenly giving them the middle finger because, oh, you're so smart, you cheated. Oh my God, oh, what a genius. Turns out I could be an asshole. Has no one realized this? I could just cheat. You're not smart if you decide to cheat. You're an asshole. So don't be an asshole. Don't cheat. It's easy. But don't worry. You've been taught not to do it since you were this big. Has anyone not been taught to not cheat? That was a double negative. I'm not sure what I mean by that. Does that answer your question? Great. All right, values and types. So, all right, we've got this output function. We learned about a function, print, and it can print things. That's great. But what did we print out? Well, we printed out a value. The value we printed out was the string. I will always be calling like sentences and words and what they're strings. I printed out the string, hello world. That's what I printed out. Or in this case, whatever you just printed out is the value you printed out. The thing, pardon me, the thing you put between those parentheses was the value that you printed out. And that value had a type. And its type was string. And you can actually find out the type of something. So I said print hello world. Great. I can also go down here and do print the type of, actually we can get rid of that print just for now, just for demonstration purposes. I can ask Python, well, what was the type of this thing? And it says str. And what does str mean? It means string. Because I guess writing out string is just too difficult. They had to shorten it to 3 letters. So it actually has a type. Now that's just the string, hello world. But there must be other types. So I'm wondering, what if I put in like a number here? That's a 1. It prints out 1. Great. And what is 1? What type is 1? Someone yell it out. It's an integer. Right? So let's just verify that fact, right? 1 is an integer. Do we all agree? As far as I know. Python seems to think that 1 ain't an integer. It thinks it's a string. And here's why. Because although 1 is an integer, I didn't give it the integer 1. I gave it the string 1. The string containing the character that also is the symbol for the number 1. And the reason I know that is, well, 1, it's telling me, but 2 is I put it in quotes. We don't need to put the thing we're printing out in quotes unless it's a string. So there, I printed out 1 without quotes, and it still shows a 1. And now if I hit run on the type where it doesn't have quotes, now it says int. So now the world makes sense again. It is, in fact, an integer. It was just because I had it in quotes. So it was a trick question. So the things that we're going to be manipulating and playing with in our code are the values. All right? We saw strings like hello world or A, B, C, D, E, F, G. They're in quotes. Things in quotes are strings. Integers, 7, 42, 97, those are called integers. And then there's also things we call floating point numbers, which is just a fancy way to say it's got decimals. Okay? So floating point numbers, 3.792 and 0.0000, whatever that is, 5. So right now we've seen 3 types: strings, integers, and floating point numbers. Let's see what happens if we play with a float. Real quick, see how it reacts. 1.1. It's a float. We print it out. We see a float. Even 1.0, which is equal to the integer 1, is still a float. It's got a decimal. And there's a reason for this. It's because within the computer, they're actually like represented a little differently, but we're not going to worry too much about that. So we've seen 3 types: strings, integers, and floats. Now the values I just showed you there are what we call literals. They are the value they have, like they're literally what they are. The integer 1 is literally 1. 1 means 1. It's just, that's it. To be clear, the fact that they're called literals, I think I only ever use that phrase once a year, and it's in this class. At this, like, day 2 of 161. Its value is a literal. We call it a literal. It's just the value 1. You might see bugs in Python eventually where it mentions literal. It's referring to a situation where, in fact, let's see if I can make a bug like that real quick. Nah, it doesn't. It just says int object not callable. Whatever. So there's values, and I mentioned the associated types. Right? Strings, integers, and floats. To a computer, the integer 1 is not the same thing as the floating point number 1.0, which is not the same thing as the string 1. They are all different because they have different types. The string 1 is like the word 1. The integer 1 is the integer 1. And the float 1.0 is the floating point number 1.0. They're different. Now, integers and floats aren't too bad. If I print 1 plus 7, 1.0 is a float, right? 7 is an integer. If I add these together, we get 8. It's a float. It gives me back a float. I know that because it's got a decimal. But it's fine to add those together. But we saw that some types don't get added together too nicely. Like when you add an integer plus a string, Python goes, what the hell's that? Because it doesn't know what to do with that. It doesn't make sense. Neither do you. Yeah. So some errors you will make will be a result of mixing up types. You'll be using types incorrectly. This is common. Some languages, so some programming languages like C, C++, Java, C#, whatever, there's a lot, are very, very strict about types. Python, it's strict about types, but it gives you a little bit more flexibility. But this really won't make sense in the context of this course. But whenever you make a value in some of those other languages, you have to specify the type when making that value. In Python, you don't. It just figures it out for you. But that could also be a problem because you might accidentally mix up your types and cause some bugs. A famous one is 1 plus 1 is 11. Right? 1 plus 1 is 11, right? If I accidentally so what I'm doing is I'm doing 2 steps here. I've got the string 1, and I'm adding to it the string 1. And it turns out that addition will work if you add 2 strings together in Python. It is defined, and you'll see what it does in a moment. Yeah. Concatenates them, if you couldn't figure it out. So first, the computer is going to add those things together. And then, as soon as it's done, it's going to do the print. So it will actually, do you need to take a seat? Nope. I mean, it might be, just not right now. So this is actually going to do 2 steps. This one line of code is going to do multiple things. In general, you typically like to have your lines of code as simple as possible. Here, I'm kind of doing a bunch. I'm saying take the string 1, add to it the string 1, and then once you're done, print out the result of that. So when I hit run, if I was expecting to get 2, because I thought it was taking integers, and I have 11, is that a good thing or a bad thing? It's a bad thing. That's a bug. And these are one of the sneaky types of bugs where Python didn't yell at you. It was like, okay, I'll do what you told me to. And it did. But is that really what I wanted? Maybe. But if I was expecting this to be adding 2 integers together, like this, I'm going to be confused. Because, well, 11 ain't 2, right? So Python's nice that you don't have to be explicit with your types, but you might think, oh, good, a little bit more freedom. But not really, because you're actually more likely to make mistakes by it. So it's a perfect example of giving you more like rope to trip up on, right? You can check by printing out the type of things. I already showed you can get the type of various things. But we will pick up here on Friday. Cool.